Hello everybody. This is the second part of the 101 blockchain session. The second part was to get fake ether. So to get that, we went to the embed page and copied the URL post. We then pasted that URL post in the ring-B faucet and we clicked on give me ether. Once we did that, we got the ether on the ring-B network that we can use. So this is what we did, and I got like 3 ether. Now, the broad thing here that we want to understand is that when we are looking for a distributed app, which is like a normal app, but the backend is on Ethereum blockchain, and when we are talking about that, we want to look at Solidity programming and deploying and holding ether and launching our own cryptocurrency. So we are trying to do the green part on the right and the yellow part on the left. So MetaMask is the tool that we installed. It's going to hold our fake ether, and we are going to see the tokens there. So you are required to install MetaMask and extension, get fake ether from Fauthor ESET. And once you have that, then you can deploy any code. To understand the smart contract and Solidity, you have 3 things. You have address, functions, and currency. Address is for the user and for the contract. Functions are used to do any function that you want to do, like reading something, writing something, transferring money from here and there. And currency is like the tokens and the Ethereum and the gas, with the 3 things that we are going to deal with. So we are trying to record all the transactions on Ethereum blockchain, and to run a contract, which we are going to write in Solidity, we can run it on 3 things. Javascript, which is your browser. It's local memory only. Injected Web3, which is provided by ring-B. We are going to use injected Web3 and write it on the ring-B test network. And we have Web3 provider, which we could run on the local host. So if you have a local Ethereum blockchain running, then you can talk to the local host. And that's why if you see here in the Web3, he says localhost 8545. So the broad idea about the dApp is that the front end would be the same, but the backend would be Ethereum blockchain. So all the transaction and information that you want to store about the user and user transaction, you would store it on the Ethereum blockchain. So we have the fake ether. We can check it. I just showed you that I got 3 fake ether. Inside a contract, we have the name of the contract, the address, constants, function. We need to understand inheritance and defining some arrays, which are like Python dictionaries on, and finally the implementation on Ethereum blockchain. So we want to understand the data types, see some functions. Functions take some input and gives us some output. Identify the arguments and the return values of a function. And to do that, we are going to use the set age and the get age. So in this function, the name of the contract is my first contract on the top. It's Pragma Solidity, the name of the programming language. String private name and uint private age are the 2 variables which are private. Then you have in total 4 functions here. Set name, get name, and set age, get age. Set name function has some input, which is an argument, and the input it stores into this variable, which is the name. And return returns the name but does not take any input. Here it's like a blank parenthesis. And same with the set age, it takes the new age and sets it to this variable. And these variables are being held in this contract, which is on the Ethereum blockchain. Another thing that we did was contract public constant, which is to save the contract with some public information. We could save our name or our will or any promise that we made to somebody on this public constant. So we have 3 constant, and these 3 constant could be read for free, which we tried to read when we created this, and then we shared the contract address. Coming back to the get age and set age, you have the return thing, which talks about whether the function returns something or not. It's going to cost money to get something to run a function because these are not public constants. Then we ran the big code to create our coin. We had things like initial supply, we had things like the name of the coin, and so on. And then we launched our token, and then we transferred our token to each other. One of the concepts that we are going to see often is inheritance, and the next is this mapping, which is used to create an array. So whenever you see mapping and this symbol is equal to and this sign, it creates an array. So and then we have arrays inside an array, which is a 2D array, which is similar to Python dictionary or JSON object. And possible projects that we can do with Solidity would be ICO contract or betting contract or voting contract or fund rating application or lottery. One of the other examples that we do in the whole day bootcamp is banking examples. And we have to also look at modifiers and error handling. Modifiers can be used to change the value of behavior of a function. For example, they can check automatically whether a condition is satisfied. We use this to make sure that some of the functions are run by the owner of the contract or the user of the contract or whatever we want to write. Modifiers are inheritable property of the contract and may be overridden by derived contract. So that was in very short what we have been doing. I hope this was useful and thank you for watching.